Okay guys, we are going to do the second part of 12.2, which is now we're going to get into how do you find the surface area of a prism. So first let me define what a prism is. A prism is a three-dimensional figure where all of the faces are polygons. So that's what a prism is. So all faces are polygons. And if I take a look at it, this is what we would call a rectangular prism. You name a prism by the shape of the base. So as an example, let's just say that this down here, and highlight that, down here is the base, and then obviously you're going to have another base that's going to be congruent, be the same figure, right? So if these are the bases, then you would say, okay, what's the shape of that? That is a rectangle. So we would call this a rectangular prism. Oops, and I can't spell rectangular. There we go, rectangular prism. So these would be the bases, and then all of these that are kind of wrapping around it, those are called the lateral faces. So for instance, this right here would be a lateral face. We also have all of these edges that go around. That's called a lateral edge. And then all of the edges around the bottom, so down here, down here, down here, down here, those would be called the base edges. Now this particular prism is standing straight up and down. So this would be what we call a right prism. My cat just jumped on the table. Oh my goodness. Okay, right prism. And that is where your lateral, we'll just say this, the lateral edges and base edges are perpendicular. The lateral edges are perpendicular to the base edges. So in other words, right here, that forms a 90, that would form a 90, and so on and so forth as you go around the figure. So this is a prism. Now, we call this a right prism, and then the opposite of that, actually it's not even really opposite. Let me grab this paper here. So I'm not writing on the back of it. There we go. Notice that this one is not standing straight up and down. It's kind of tilting. This is still considered a prism, right? Because all of the faces are polygons, but this would be what we call an oblique prism. And all that means is that it's slanted, right? So the lateral edge and base edges are not perpendicular. Are not perpendicular. I mean, it's still a prism. What would we call the name of this prism? By the way, let me say one more thing about a prism. All faces are polygons. I want to add something to that. All lateral faces. This is lateral. Let me write that better. All lateral faces are rectangles. Okay? All the lateral faces are rectangles. So when I come back and look at this and I would say, okay, well, what's the base? Well, remember the bases are, maybe they're rectangles, maybe they're not rectangles, but we know the lateral faces are rectangles. So notice that the bases for this one would have to be down here. So this would be a triangular, remember it's named by its base, prism, and it would not be right, but it's still a prism. So what happens is the height of the prism is actually this guy here, right? So this right here is actually called the slant height, And usually, and we'll get into this when we get into the pyramids, we use the letter L for that. That is your slant height. Now, for today, we're just going to be dealing with the right prisms. So you don't really, just know how to identify these, but it's not, most of the time, we are going to be looking at right prisms. But we're going to be looking at how you find the surface area of a right prism. So the surface area is, if I take a look at this prism right here, and I'm going to work backwards, I'm going to look at it like this. How would you name this prism, right? Notice that the faces are hexagons, so this would be a hexagonal prism, right? Well, if I were to unfold this prism and lay it flat, it would look something like this. This is called a net. So if you're asked to draw a net of the prism, that means pretend that you unfolded it and laid it flat. So the surface area would be finding the area of everything here, including your bases. So it would be finding the area of each of these lateral faces. So it's the area of the lateral faces. Area of lateral faces plus the area of the bases. That is surface area, okay? Lateral area is finding the area of just the lateral faces, do not include the bases. So that one is just the area of the lateral faces. So as you read the problem, it may ask you just to find the lateral area, or it might ask you to find the surface area or total surface area, which would be everything, right? Versus the lateral area, which would just be the faces, okay? And by the way, this is a hexagonal prism. So if you think about what we did last class, and I keep saying class like we actually met, last lesson, how do you find the area of a hexagon, right? If I wanted to find the surface area, I would have to figure out the area of the hexagon. So we had to learn last class how you find those areas so we could add them in for surface area, okay? All right, so moving on, I think we're just gonna, I'm gonna give you the formulas and then we'll do a few examples and we're done. So how do you find the surface area? So here is the formula. You're going to, we call it SA, and that stands for surface area. It is going to be equal to 2 times capital B plus little p plus h. So let me tell you what all of these letters mean. Capital B stands for the area of the base. And the reason why we have 2 of them is because there's 2 bases. So if I go back to that net that we just had, right, I would have to find the area of the base and times it by 2 because I have 2 of them. Little p stands for the perimeter of the base. Okay? So that is going to be the perimeter of the base, and then h is the height of the prism, or you can think about it as a lateral edge. So let me go back to that diagram again. So if I'm looking at the figure here, and then we'll look at it over here. So here would be a base, right? So we've got a capital B here, and then you've got the one in the back here. Then you would find the perimeter of the base, right? This right here would be your lateral edge. That's the height of the prism. It's basically the distance between the bases. So if you wanted to add that information in, you could. So maybe we could do another parenthesis, distance, or maybe we could add it right here. Distance between the bases. Okay, crumb there. Okay. All right, so let's do an example. So first of all, let's take a look at it. We're told that it's a right rectangular prism, and that means that my bases are rectangles. Well, if you look at the diagram, all of the faces are rectangles. So on rectangular prisms, you can actually decide, what do I want the bases to be? Do I want the top and bottom to be my bases? Do I want the front and back to be my bases? Do I want the side to side to be my bases? I am going to decide and choose to make the top and the bottom, I'm going to make those my bases. So the first question says, what is the perimeter of the base? So here's one base right here. So I know that I have a rectangle, right? Because I'm told it's a rectangular prism. So I've got 8, 3. So I know over here is going to be 8, and I know back here is going to be 3, right? So the perimeter is going to be 2 times 8 plus 2 times 3, which is going to give me 16 plus 6, which is going to give me 22 centimeters, and there's the perimeter of the base. Then they're asking me for the length of a lateral edge. Remember, a lateral edge is going to be the distance between the bases. So right here, that's going to be your lateral edge, and the length of that is 5. What is the lateral area? Oh, let me come back up here for a second. Let me give you one more thing. The lateral area, if you're ever asked to find that, just take away the bases. The lateral area is simply the perimeter of the base times the height, if you're ever asked that. Well, if I want to find the lateral area of the prism, then I need the perimeter, which I already found, times the height, right? So I would say 22 times 5, which is going to give me 110. So you're going to take 22 times 5, which is 110 centimeters squared. So that's going to be the lateral area. And now we want to find the area of the base. Well, to find the area of the base, it's a prism. Let me move it over just a touch. It's a rectangular, right, prism. So we know it's a rectangle. How do you find the area of a rectangle? Your capital B formulas will change depending on what your base is, right? So if we've got a rectangle, it's going to be length times width, which is going to be 3 times 8, which is going to be 24. So the area of the base is going to be 24 centimeters squared. What is the surface area? So we're going to say 2 times 24 plus the perimeter of the base, which was 22, times the height is 5. Well, remember, we already found pH. That's 110, right? So we would have 48 plus 110, which is going to give me 158 centimeters squared, and that would be my surface area. Okay? Okay, let's go to the next page. We want to find the surface area of the right prism. So if I take a look at this, notice that I have triangles as my basis. So this is a triangular prism. And remember, one of the things that we're going to need to do is find the area of the bases, because I want to find the surface area. So what kind of triangle am I dealing with here? Notice that each of the sides is 7, right? So this is a base. And then back here we've got a base, right? Well, that is an equilateral triangle where all the sides are 7. How do we find the area of the base, right, of an equilateral triangle? Well, if you go back to the lesson that we did, hold on, let me grab it here. Lesson that we did on the last one, the formula that I gave you for an equilateral triangle to find the area, it's 1/4 the length of the side squared times the square root of 3. So you have that formula there, right? So the area of the base is going to be 1/4 7 squared times the square root of 3. That's going to give you the area of the base, right? So we would just have to calculate that. Okay, so let me grab my calculator and clear that. So, oops, sorry about that. So we're going to say 49 divided by 4. And we're going to take that times the square root of 3. And I get about 21.2. So capital B is going to be 21.2 meters squared, right? All right, so now I'm ready to find the surface area, right? So remember, the surface area is 2 times the area of the base plus the perimeter of the base times the height. Well, the perimeter of the base is just going to be 7 plus 7 plus 7, right? So perimeter is going to be 7 times 3, which is 21 meters. And the height of the prism, remember, is the distance between the two bases. That's going to be 5. There you go. So that's everything that we need, right? So now we're going to fill it in. 2 times 21.2 plus the perimeter of the base, which is 21, times the height is 5. Okay, and we can go ahead and calculate that out. So I know this is 105. And so we would go 2 times, I guess I could have left it on there. So 2 times 21.2 plus 105. I don't know. Oh, I don't know what I'm hitting here. 21.2 times 2 plus 105. I got 147.4. And there's your surface area. And that would be in terms of meters squared. Okay. The last figure is easy breezy. We want to talk about a cylinder. So a cylinder is kind of like a soup can. If you take a look at the bases are always going to be circular. So a cylinder is a solid with congruent circular bases that lie in a parallel plane. So how do you find the area of a circle, right? So here's your formula for the prism, right? So the height is the distance between the bases, or you could look at height up here, right? So to find the surface area, it's the exact same formula except it's in terms of a circle. The area of the base is going to be, how do you find the area of a circle? Pi r squared, right? So it's going to be 2 pi r squared. How do you find the circumference of a circle? That's 2 pi r and the height, and there's your formula. And once again, if I wanted to find the lateral area, it's just going to be this part here without the bases. That's going to be 2 pi r h, okay? So I think I just have one example for us on cylinders because it's pretty straightforward. Yeah, I just have one example. So I'll leave that there so I can bring this here. So it says find the surface area of the right cylinder around the result of 2 decimal places. So here's my radius. Notice that it's 8, right? So we just need r, and then the only other thing I need is the height, which is going to be the distance between the bases. Notice that that is also 8. Coincidence. So the surface area is going to be 2 pi 8 squared plus 2 pi 8 times 8. So 8 squared is 64, right? 64 times 2 is 168 pi. And this is actually going to be the exact same thing. So I'm going to add those together. 168 plus 168. 8 plus 8 is 16. Carry the 1. 12, 13. Carry the 1. 336 pi. And then that's going to be in terms of centimeters squared. Now, do we leave our answer in terms of pi? Well, in the problem, it's going to either say round, which means we're going to calculate the pi out, or it could say leave in terms of pi. If it says leave in terms of pi, there's your answer there. But it does say that we want to round, so I need to clear that. And I'm simply just going to hit 336 times pi. So 336 times pi is right here. And I get 1055.6. So my surface area is 1055, round to 2 decimal places, so that would be 0.58, and that would be in terms of centimeters squared. Okay, guys. All right, so those are the notes. Let me go ahead and take a look at the worksheet that I have somewhere over here. Let me find it. Okay. So what you're going to be doing is finding the surface area, lateral area. This one right here is real similar to what we just did. Notice that this is a hexagon, right? It says give the mathematical name of the whole solid. So remember, if your bases are a hexagon, what would you call that? And so it's just asking you to do those kind of things here. Remember, these are called nets. If you were to fold them out, if you folded them in, what kind of figure would you have there? Here you're finding the surface area. Remember, you're going to find the area of the base. Let me review with you. How do you find the area of a trapezoid? Because that's a trapezoid prism. So I'll write it up here. Actually, I'll just write it on the back. So the area of a trapezoid, I'm going to review that. This is your height. Makes that 90-degree angle. This is your base. And then you also have a base down here. So that's not a squared, that's a sub 2, sorry. So the area of a trapezoid is 1/2 the height times the sum of the bases. So that's how you find the area of a trapezoid, okay? Now, if you look at this, it's really hard to see. I know it's really dark, but right here, this is a oh, I'm gonna change colors here. This right here, they're telling you that is 6. Okay, I don't know if that helps you, but it's really, really dark on my worksheet. So I just thought I would tell you that on that one. I don't know if there's any other numbers that are hard to read, but I know that one, your height of the trapezoid is 6. Okay. Okay, so now I thought I would do one of these down here at the bottom. It doesn't, they're all kind of the same thing. It's saying solve for the variable given that the surface area of the right prism or cylinder result to 1 decimal place. So as an example, if we look at number 15, you are told that the surface area is 208. We want to figure out what x is. So the first thing I would do is say, okay, what's the formula, right? So the formula for the surface area is 2 times the area of the base plus the perimeter of the base times the height, right? So if I look at what I know the height, because we'll just say the top and bottom are my bases. I know the height, so I know h. I don't know the perimeter because I don't know what the perimeter is down here. And I don't know the area. Now, actually, because this is a rectangular prism, you could actually make the top, the side to side your bases and do it that way. I mean, you're going to get the same answer no matter what you do. But if you want to say, okay, well, what's the area of the base, right? The area of the base is the length times the width. So the area of the base is 4x, right? The perimeter of the base is 2 times 4 plus 2 times x, right? So the perimeter is going to be 2 times your length plus 2 times your width. So the perimeter is going to be 8 plus 2x, right? And you know the surface area is 208, so it'd be 208 equals 2 times 4x plus 8 plus 2x times the height of the prism, which is 8, right? And then you could solve that, right? So it's not a quadratic, it's just a nice, easy breezy linear, right? So you get 8x here, distributing, we get 64 plus 8x equals 208, and then we get 16x plus 64 equals 208, and I'll let you solve it from there, right? So you would just subtract 64, divide by 16, and boom, there's your x, okay? So figure out what capital B is in terms of the variable that you're trying to find. Okay. Here you've got a right triangle, so you know that this is 6 because see that it's isosceles. How do you find the area of a right triangle? Well, that's easy. 1/2 base times height. What you're looking for here is this h, right? How do you find the perimeter of the base? You could use the Pythagorean theorem or know that it's a 45, 45, 90, right? So you should be able to figure that one out. All right, guys, so that's it on 12.2. All right, we'll talk to you soon.